Let us go into graphing. Let us sketch the graph of functions of the form y is equal to a times sine of bx. So this is your guide. First, look for the period. The period is equal to this, and what it will give you is the length of the interval that contains one sine curve. Okay? The period is equal to 2 pi divided by b. Next, you will find the amplitude. You will pay attention to this. The absolute value of a will tell you the amplitude of your function. And at the same time, it will tell you the maximum and minimum values of your function. So let's say, for example, this is the maximum, 0.5, and this is the minimum, negative 0.5. So that means your graph will not go beyond those two lines. The graph will be contained within those two lines. So what do you do next? Well, you look for the x-intercept. You look for the x-intercept. The x-intercept is where your function will intersect the x-axis. And then you plot the points. You don't plot all the points, okay? What you do is you plot the x-intercepts and what? And let's say, for example, the x-intercepts are this. 0, pi over 2, and pi. And then you plot the maximum points. Between the x-intercepts will occur your maximum or minimum points. And then you trace one curve and you repeat. Okay, you repeat. Something like that. Let us sketch the graph of y is equal to negative 2 times sine of 2x. So right away, you know the period. The period is 2 pi divided by 2, and that is equal to pi. So from 0 to pi, we shall have one sine curve. Now, what is the amplitude? It's equal to 2. And right away, that is telling you something. The maximum value of your function is 2, and the minimum value is negative 2. So right away, we know right away that your curve will be confined within these two lines. So what else? We look for the x-intercepts. So the x-intercepts are the value of x, so that the value of your function is 0. So what you do is you equate this to 0. When is this equal to 0? But you know sine, yeah? You know the sine function. And you know that the sine function is going to be equal to 0 when all of this is equal to 0. Okay? Because sine of 0 is 0. Sine of pi is 0. Sine of 2 pi is 0. So solving for x is equal to 0, pi over 2, and 2 pi divided by 2 is pi. Okay, so let us plot them. Okay, so 0, pi over 2, and then this one is pi. So you will have one sine curve in this interval from 0 to pi. So what else? Let us now plot the maximum and minimum values of your function. So the midpoint of 0 and pi over 2 is pi over 4, okay? Pi over 4. And so what you do is you compute for negative 2 sine of, what is that equal to? This one, 2 divided by 4, that's 1/2. Sine of pi over 2 is 1 times negative 2 is negative 2. So here, when x is pi over 4, the value of your function is this one, negative 2, okay? What else? So this one is going to be the minimum, okay? Minimum value of your function. And the midpoint of pi over 2 and pi is 3 pi over 4. So you know what's going to happen. At 3 pi over 4, Okay, the value of your function. Okay, so let's compute for that. Let us compute for that. Okay, so negative 2 sine of, okay, 2 divided by 4 is 1/2. So this becomes 3 pi over 2. Sine of 3 pi over 2 is negative 1. So negative 2 times negative 1 is positive 2. So here, your function will achieve its maximum value. So look at this. X-intercept, minimum value of your function. X-intercept again, maximum value of your function, and again the X-intercept. You trace one sine curve. And then you repeat. How about that?